Okay, example 5-1 is about a concrete trapezoidal channel with a Manning constant of 0.013 and with the bottom width of B0 equal to 6 meters. So the sidewall slope is 1 meter, 1 vertical to 2.5 horizontal, and bed slope is a 0 equal to 0.25%, so 0.25%. So it carries a discharge of 16.5 cubic meter per second. And the question asks to determine the channel classification. So we want to know whether the channel is mild, critical, or steep. So we want to know which one of those flow classification we have in this particular channel. So basically what we need to solve for is the critical depths and normal depths to compare. So for critical depths in general channel cross section, we have Froude square is equal to Q square B divided by GA to the power of 3 is equal to 1. So the value of depth in the left-hand side should be selected somehow. That gives you the right-hand side equal to 1. So the discharge is known, 16.5 square. Top width is B0 plus 2my, 2 times m, which is 2.5 times yc. So the only unknown is yc here. In denominator, we have 9.81 times area, b plus my times y to the power of 3. Okay, so we use Excel. So in Excel, I developed the equation for Froude number and for Manning's constant. So if you go back to the note for normal depth, we have Q square is equal to A over N, R to the power of 2/3, S to the power of 1/2. So in the left-hand side, I have discharge, and in the right-hand side, I have area times hydraulic radius to the power of 2/3 times longitudinal slope to the power of 1/2. So we go back to Excel. Here I have the equation for discharge. I have B0, M, Yn, and longitudinal slope. So I start with 1. The idea is to match the left-hand side and right-hand side. So you'll see that 1 meter of normal depth provides 226.9 discharge, cubic meter per second of discharge. So I need to reduce the depth. So 0.9 still is high, 0.8, getting close, 0.7. So yeah, I have the discharge, estimated discharge below the given discharge. So I need to increase 0.75. So 15.94, I need to slightly increase discharge, maybe 7.6. Yes, more 7.65, 7.64. Okay, so very close. So 3-digit after the decimal point would be fine. So this would be the normal depths. And then I will do the same thing for Froude number. So this is the equation for Froude square, Q square plus B divided by G A to the power of 3. So I start with 1. So this is Froude square, and then the next cell is the square root of the previous cell. So Froude number 1 gives me 0.7. I need to reduce 0.8, 0.8. So it's 0.79, 0.81. So 0.81 pretty much gives you the Froude number close to 1. So maybe 812, 815, 813. Yes, so this is close enough. So I got YC equal to 0.83 and YN 0.76. So here you'll see that YN is smaller than the critical depth. So it means that the flow is supercritical and the channel is steep. What else I can do is I can put the value of YN to see what fruit number I will get. So 0.7645. So it gives me a fruit number slightly more than 1. So it shows that the flow is supercritical. Okay, so we get YC 0.1813, YN 0.7645. So YN is less than YC, and the channel is steep.